So, hello and welcome to finally another episode of Flying High with Flutter. I'm your host, Alan Wyma, and today we have another very special guest. He is Garrison Hinson Hasty, the author of Systems Programming with Zig. Hello there, Garrison. How are you?
Hi there. I'm doing pretty well, Alan. How are you?
Long time since we've actually done an episode, so I'm happy that again Manning kind of reached out to bring on another one of their awesome authors, and I'm kind of really excited because you wrote a book about Zig, and I don't think Manning had any books about Zig last time I checked. Is that right? You're the only book about Zig I think on Manning.
Yeah, I'm definitely the only Manning book about Zig. I think I'm one of the first books about Zig in general, which is pretty exciting to have that opportunity. Um, yeah, so I'm excited. I'm excited to be one of the first authors.
Really? There's no other books about Zig that you can think of, or maybe not that many in general.
I know there's an open source book that seems pretty decent. I think it's Pedro Park, something like that. I'm sure I'm getting that name slightly wrong. Who's writing that one? And I think that one is. I did notice that book when I was originally working on the proposal for the book. So I'm trying to make sure that I'm not stepping on their toes too much. Um, I go a little bit more in depth with my projects and a little bit deeper into some different fields that they don't touch. So
Yeah, okay. I didn't even know that because I'm thinking we were talking a little bit before the show and how I'm more involved with Rust and yeah, I mean, to me and you, there's no real animosity between Rust and Zig, as far as I know. Um, I believe the author of Zig used to actually work a little bit on Rust before, a long, long time ago. And it's kind of interesting. There's so many books about Rust, but not many about Zig. I never even looked into that. I thought there was already going to be some because in my world, I see a lot of people working with Zig, and the fact that there's no books about Zig and people are actually using it in production and really crazy about it is kind of a little bit weird, right? So, I mean, maybe we can kind of roll back a bit and hear a little bit more about like you. So, do you mind to give like an introduction about who you are and kind of your journey through programming and how you got up into Zig?
I mostly learned programming as a self-taught hobbyist. Frankly, I took some computer sources in high school or some computer classes in high school that introduced me to Python, and I got really into Python for a long time, just building anything I could I could figure out how to build. Um, and it wasn't until in college I went to Case Western Reserve University. They have a really great computer science program there, very prestigious. There's a lot of research, but I did not find that I meshed with the program very well. So um, in college, and I think after starting that program, I felt a little bit discouraged about programming in general. And the main thing was that I have a lot of passion for programming. I really enjoy the act of doing it. I really enjoy the act of making things. I enjoy putting in a lot of time and effort into understanding something deeply, and then having something to show at the end of the day. Um, and I didn't find any of those values in the program. And that's not it's not to say that the program is bad. It just wasn't a match for me. Um, so I think I entered college in 2018. When COVID happened in 2021, I had a lot of extra time on my hands, and I think I just had like some Casey Muratori videos or something pop up on my YouTube, and it got me reinvested in uh, programming because I was seeing all of this stuff about the C language, and I had never think that again understanding things at a low level. I really saw in some of these like C programmers, video game programmers, things like that. And so I spent about a year working on like my own little game to pass time in COVID, and that was in 2021 was also when I found Zig eventually, because I think I found that one through. There's a guy named Randy Gall who builds a lot of small open source uh, video game infrastructure. I believe he worked at Epic or works at Epic now, and he was writing about uh, some of the different designs that systems programmers use and programmers use that you wouldn't have encountered in a higher level language like Python. And I think that brought me to the Zig language. And Zig basically the first thing that I knew about it was that it was taking a lot of these ideas and more modern ideas in C that I was encountering as far as like higher level systems design, um, and was adding a bunch of new modern features like metaprogramming, um, and putting those all in like a nice package. So that was what brought me to it. And I think since then it's basically just been a love affair. It's been the main thing that I have wanted to build things in. And even when I reach out to other languages, I love learning programming languages. I've learned a lot of different programming languages, but I always come back to Zig because of just the level of thoughtfulness put into the ideas and the amount of things that you can do with the language. Um, and I've touched the compiler a little bit. I've touched on the community projects. I've read large pieces of the compiler. So I think that fundamental enthusiast, I've written a lot of Zig, talked to the community. I've spent a lot of time in community forums helping people learn the language. Um, Alongside that, I also do cybersecurity research. So I work with UChicago's Supergroup Lab under Blaze Erb, who's a very awesome professor to work with. And I've been able to use Zig to solve some interesting research problems as well. So I could talk about that a little bit too.
Actually, I would like to talk a little bit more about Zig itself, right? If you were to describe like almost like an elevator pitch to somebody, like, you know, what is Zig? How would you kind of explain it? Because it is kind of it's a weird kind of language, because most languages are like, oh, we're here to replace C, or, you know, we're just another, I don't know, higher level language. I mean, how would you kind of give it the pitch?
So I think that the main thing about Zig is the values that Zig holds. Fundamentally, the compiler team and Andrew Kelly himself talk a lot about how until Zig is 1.0, they like can and will break anything about the language. And the reason they say this and repeat this is because Zig is fundamentally about Zig Zen is about the values of uh, and really to me to some of like my condensed version of values is something like deeply understanding code at the lowest level is the best way to write reliable optimal code, and it will also save you a ton of time in the future. And so I think there's a lot of different places to go with that. So Zig is also built to be a systems programming language, so it lives in a very similar space to C. Basically, anything you can write with C, you can write with Zig. There's some things you can write with Zig that you could not write with C because Zig adds some extra level of features that C doesn't have. Of course, C has a ton of language extensions and a million ways to do different things and integrate with assembly. So, but Zig is an easier language, I think. It also lives at a similar place to Rust in some aspects, especially with Zig's newer web server capabilities in the standard library, which is something I've experimented with a lot. I think Zig also has a ton of new ideas that are. I should say that most of Zig's ideas are actually just taking, like I was talking about before, they're taking modern systems programming ideas from C, C++, and Rust, such as allocators or something that existed in C and C++. Also, just thinking about memory in terms of buffers, thinking about like different kinds of allocators. Zig's new async model, I think, is unifying a lot of different ideas, but I think that is something fundamentally new. So I know I'm throwing out a lot of terms that we haven't gotten into yet, but Zig basically is taking a lot of these like best ideas that we've seen in systems programming in the last few decades and trying to put them all in one nice package. Also comp time. Zig has amazing metaprogramming, and I think that it is also a different kind of metaprogramming than Rust. It's also something that people really like in Rust. But Zig has really world-class metaprogramming that is just built into the core of the language. So I think Zig has a lot of awesome ideas, and it's all built around the values. Yeah.
Yeah, I was just trying to look at some of these keywords that you mentioned. I mean, you mentioned quite a few different keywords. One that I definitely seen come up in my research over again about kind of Zig is about allocators, and so I mean, I don't think many people even really get into that unless, of course, you're dealing with some very like niche hardware, right? Maybe I'm wrong, but that's how I see it as. And could you mind like do you mind to kind of give a little bit talk about like what's an allocator and why should we really kind of care about it?
Yeah, absolutely. So I think that, yeah, exactly what you said, I think is uh, what the general mainstream, if someone's heard of allocators, they think of it as a very niche thing. They think of it as something that people might do in an embedded space. Um, but in Zig, an allocator uh, is something that everyone needs to think about. And there's very good reasons for this. So when we're thinking about memory in C or Rust, um, when we allocate memory, so when like we need to uh, build a string or we need to store like a list of items somewhere, that memory needs to come from somewhere. Um, so in like garbage collection language, with which most people are familiar with, there is a runtime to the language, which is a giant bundle of code that does a lot of stuff that you might want to do. So when you're creating an object in Python, for example, the runtime is going to think about all this for you. It's going to think about when that object needs to be created, when it needs to be deleted. Um, in Rust, for example, it's very different. The runtime still does handle allocation, but the compiler in Rust thinks is able to reason much more clearly about when we need memory. And Rust also has the lifetime idea baked very heavily into it everywhere. So you are also able to think pretty clearly as an experienced Rust programmer about where memory is going to be required and when it's going to be released back to the operating system. But inside the Rust runtime, there is an allocator somewhere, and what the allocator does is allows you to request that memory and allows you to release that memory. And internally, the allocator is going to your operating system typically and asking the operating system to give your process more memory. Um, and this is sort of all what it goes back to, is that we have these operating system fundamental ideas of we have a process which has instructions that are like CPU instructions that are executing. It has memory that the operating system allows you to access, um, and our language runtimes tip in most cases are handling that for us, or at least providing us a more convenient interface. Um, so in C, it's we have malloc and free, which you might have learned in like your CS operating systems course or whatever, where we have a little bit nicer interface than the operating system one, where we're able to ask for uh, just like a number of bytes, and we can just allocate that from the allocator, and we can free it back to the allocator, and that's it. We have nothing else pretty much. In Zig, we instead have a big set of different allocators, and also an allocator is something that you yourself can build. So what this means is that um, we are not locked onto any single language runtime, and you can write Zig code without ever using the standard library's built-in allocators. You can write your own allocator. You can choose not to use an allocator. And so that immediately has the effect of massively slimming down the amount of code that your Zig programs are actually using. And it also means that you can think about all of the memory you're allocating in a very different way. So you can think about when you're allocating memory, you have a much better understanding, because you're choosing the allocator. You have a very good understanding of how that memory is getting allocated, when it's getting released, and what responsibilities you as a programmer have to that memory to allocate or release it. And I can talk more about these ideas, and I hope that was mostly clear. Um, but fundamentally, allocators are about providing a level of control, and providing a consistent API so that people writing Zig code can reuse code with different allocators, can write code that works on a vast variety of hardware and operating systems, or lack of operating system. Um, yeah, so I hope that wasn't too overwhelming.
No, no, no. Please. I mean, I find this stuff super interesting because it's amazing how like we just write the code that compiles the code, and I my personal thing. Maybe I'm being a little bit too kind of I don't know what the right way to just kind of more casual about it is. Like, I think 99.9% repeating amount of developers don't really think too much about it unless you're in like some specific space, right? So it's interesting to hear kind of what's actually happening behind the hood, or under the hood. Um, I mean, there's many different features of Zig that's quite interesting, and it's just like Zig is just another programming language. Well, not necessarily. It's got a lot of interesting features. Like for one thing, we talked a little bit about this again before the show. It's like you can actually compile it with different levels of safety. I believe it is. There's different levels of compiling. I forgot what it's. It's been a couple years since I talked with the creator. Like, do you mind to kind of talk about that because that's also super interesting too. Because like people will talk about Zig is for X. I'm not exactly sure how people would kind of say it, and Russ is more of a. Even today when I did my research, like I said, Rust is more into safety, and if you really care about security, go for Rust.
Yeah, absolutely. Yeah, I think you really hit the nail on the head with just um, like Zig reveals these layers of abstraction that we're used to in a new way and lets you think about them in a very nice way. Um, so I think that's also why I was talking earlier about how Zig is more of a set of values and the language reflects those values well. Yeah, the release modes are really cool. So um, basically, the main allocator. So Zig provides a very different set of memory safety tools than you would see in something like C or something like Rust. Um, and I mean, importantly, also memory safety tools are not something or memory tools in general are not something you see very much in garbage collected languages. It's sort of hard to get access to like how much memory um, your like Go program is using or Python program is using. Um, but this is one reason why people want to choose manually memory managed programming languages is so that they can control these things, and so that when you're uh, 20,000 lines into your production application, you're not, and you come up against memory limits, you can go back and reevaluate these things instead of having to rewrite things from scratch. Um, so basically, the Zig handles memory safety mostly at runtime. Um, so Zig provides some helpful features to allow you to manage memory manually more easily than you would in C and perhaps C++. Um, so Zig provides like defer, for example, which uh, defer basically it also exists in Go. It allows you to uh, at a certain point in a block of code, you can write a defer line, and um, basically, if you exit from that block at any point after that defer line, the expression in the defer will be executed. Uh, so this allows us to think about, for example, if you allocate a buffer and put a string in there, you need to free it at some point later on, and defer. With defer, you can after you declare and allocate that string, you can on the next line defer freeing that string, and then you've defined a lifetime for that string that is just for that block of code, and you've explicitly stated all like everything that's going to happen. And so from that point on, if you exit with an error, if you return somewhere, if you break from a loop, at any of these points, the free is going to run. So defer is a really awesome tool for just making this manual memory stuff more easy. Um, so next we have the the debug allocator. So debug allocator is typically the allocator that implementation that at least I use for as a baseline starting out until I have some reason to think about the way I'm allocating memory. So debug allocator, when you allocate and free anything anywhere, it tracks where that that uh, like individual piece of memory came from. So if you free something twice, if you fail to free it, it can then report to you at the end of your program executing, or when you deinitialize the debug allocator. It can report to you exactly where you have memory leaks, which is just amazing. And that it is all built with just regular Zig code. You can rewrite debug allocator if you wanted to. It's not using any fancy tricks. Zig just provides all of the tools that you need to do something like this, which is really awesome. So then we have the different release modes. So I think if you don't tell the Zig compiler what release mode you're in, by default you're going to compile the code you're writing for debug mode. Debug mode has a number of different like extra things that it does to help you with memory safety. The main thing is that it has what's called spatial memory safety, or spatial memory. I don't think I'm getting that term exactly right, but it checks spatially. So meaning like where in the memory of your process you have something allocated and where you don't. And so if you attempt to, and so this is important because if you try to write to a memory address that you have not allocated, it will provide you with a helpful error message instead of your operating system giving you a worse error message. So typically, if you've ever written C or a similar language, you've probably encountered a segmentation fault before. So what this means is basically that in Zig, we don't get segmentation faults. In debug mode, we get a helpful error that is more descriptive and tells us a lot more and allows us to fix things a lot easier. So there's also a mode called release safe. Release safe also does this kind of memory checking. But it enables a certain set of compiler optimizations that wouldn't interfere with this memory kind of memory checking. So that gives you a lot of assurance that you're not going to break things. So if you're working on an embedded system you don't want to crash, release safe would be pretty useful. Similarly, if I'm writing a server, or any other kind of code that's running for a long time, I would choose something like release safe. There are also the other modes are release small and release fast. So release small is really useful. The main reason that I use it is for WebAssembly code. So it enables all the compiler optimizations that would shrink the size of your binary, and it doesn't enable any optimizations that might make your code run faster but expand the size of your binary. So for something like WebAssembly, where you're serving a blob to every client, smaller is just better. And release fast it takes away all of the possible checks, and just gives you the fastest binary it can. And Zig is really fast compared to Rust or C or any of these other languages. So, yeah.
Yeah, it's interesting to talk about really fast. I was again in my research about between Rust and Zig is that they talked about there's some kind of benchmark that I forgot who's running it, but I guess he was interviewed on oh wow, I forgot it was the Lex Friedman podcast, and he was talking about whenever there was an update and one language became faster than Zig, then the Zig people become crazy and try to get the fastest speed. But I guess they have a pretty fast speed for this test that they were doing. I'm not sure if you've ever seen this. Sorry, I'm just kind of throwing something out there, but I guess they're really crazy about release speed or running speed. Sorry.
Yeah, I've seen a number of random blog posts of people testing different things. So Zig, at least for now, they're moving to their own self-contained compiler backends. But currently, it uses LLVM, similar to Rust also uses LLVM. Most C programs or C++ programs that compile with Clang will use LLVM. And so what this means is that the language is compiling to a sort of internal format, or they're compiling to the LLVM internal format that represents the code that they want to compile down to machine code. And then LLVM does the rest of the work, taking that and turning it into machine code. So like I said, Zig is working on a much faster backend faster in terms of how fast it compiles the code, that will eventually be comparable and maybe even produce faster machine code than LLVM does. But for a lot of these tests that I've seen in the past few years, they've been using that. So that's something important to mention. The optimization comparison is really just about what we call the compiler front end, where you're turning the text that represents the source code into the intermediate representation. But because of certain properties of Zig and the lack of any real kind of runtime that is, so like Zig code, when you compile it, you don't have to include the standard library. Whatever you include from the standard library, it's only going to compile those functions and the data that is actually used by your code. And that's the same. That's also true for any third-party library you use. If you don't use a massive chunk of a third-party library, it's simply not going to be in the binary you compile. So at least for my, I am not someone that works on code that needs to be so massively optimized. So I hope I'm not misrepresenting this. But as far as I understand, that is the big game changer for Zig's performance is just removing so much code and producing these small binaries that are easy for your operating system to work with, easy on your CPU. And because of the Zig's language design decisions, you cannot write Zig code that has a lot of hidden side effects very easily. So this sort of pushes you in a direction where you're writing code that is easier for the computer to run rather than easier for you to think about, because in Zig these tend to be the same thing. So yeah.
There's just one more question about the language Zig itself I really wanted to ask, which was about what is comp time exactly? Because I don't think I've ever heard that
Yeah.
phrase before, or that word.
Yeah. So I think so comp time, I think, is if you've ever written any Lisp code, I think, or perhaps even Ruby, I think is a pretty good example as well. There's these dynamic programming languages where you can, where the macro system, when you're doing metaprogramming, which is writing code that creates new code. There are languages like in Lisp where you could basically, what you're basically doing is you're just writing a function that takes in some other code and produces new code. But I think so far, at least in a very at least in the systems programming world, this is not something that's happened. And compiled to machine code in the same way, I'm not sure that has existed before. And it's a very unique feature of Zig is this comp time system. So, which basically comp time is just taking all of the Zig code that all of the different syntax and semantics that you can use in your runtime code, and just giving you access to that during the compilation process. So what this means is that you are using the same control flow, the same variable declarations, the same type system, everything. And you can use that to write functions that create new types. You can use that to create generic data structures. You can use it to do file parsing at comp time, which is something I do in the book. So basically, most of the things that you can do at runtime, you can do at compile time. And there are some limitations with that are sort of inherent to the idea of doing compile time code execution. But otherwise, it is extremely unrestricted. So it's an incredibly cool feature to work with, and it's sort of hard to wrap your mind around at first because it's very different than working with C or Rust macros. Yeah.
I mean, now that we've talked quite a lot about the language, I feel like this is going to become a Zig podcast at this point. Um, I'd like to talk a little bit more about like how, as a Flutter developer, like if I'm interested in kind of playing around with Zig or adding it to my project, like what kinds of things can I actually use Zig for? What's like a great use of it?
Yeah, sure. I think that Zig's, to me, the some of the coolest things that you can do with Zig have to do with gluing together very different systems. So, one example, so like for a research paper that I am, I guess is we're submitting tomorrow. Um, one of my security research papers, we're basically working with building LLMs that model passwords really well. And without getting too into the weeds, one of the things that we had to do was basically take the output probabilities for like based on previous text, like what the next test will look like. And so we would take like portions of passwords and look at the probabilities of like the next piece of text. And there's basically a giant tree that forms if you look at this, and we needed to multiply a ton of these probabilities together and then add them. And it turns out with floating point and like the number of possibilities, we were coming up against the like smallest numbers that floating point could represent. And so I used I took like the Zig standard library. Basically, like we needed a way to represent extremely tiny numbers and extremely large numbers and multiply them together without losing accuracy. And Zig has a built-in uh, like tool in the standard library to do this. And so I wrote a Python binding layer for that, and I used Zig to like write an interface that could uh, that the Python layer could read as a C library. Um, so that's the sort of thing that you can do. It's just these like crazy integration steps. So as far as like that's something that I guess would live more at the backend layer. But Zig is also really fantastic at WebAssembly applications. So if you want to do really complicated stuff in the on the client, um, or you want to compile like previously existing C code or C++ code and make it work in the browser, you can use Zig's compiler to just compile the C++ straight up, or you can write a fancier layer on top. Um, and Zig has a lot of really awesome built-in language features to make the like this library, like system library interface, really convenient to use and really convenient to build. So yeah, those are the two main ways that I can think of.
Okay, that's pretty good. I think finally I would just kind of like to have kind of like a quick roundabout. Like if I'm interested to learn Zig and I'm considering your book, like what can you kind of describe like what you actually or how you actually go through about, how do I say this? What is your method in the book of explaining and teaching how to actually learn Zig? Like, how do you actually kind of go about it?
Yeah. So like like I was talking about at the beginning of the podcast, um, you know, for me, like Zig was like my journey with Zig started with my passion for programming and recognizing that Zig's values made a lot of sense to me and fell in line with my own values about programming. Um, and so I think that when I read programming books, there's a lot of very dry programming books out there. There's a lot of programming books that want to go through a ton of sort of arbitrary examples around syntax and semantics. They want to build things that are useful and like could be fun to build in the real world, but they spend a lot of time thinking about the microscopic vision of all these little snippets of code. Um, and the best books that I've read on programming. So I think about uh, like building interpreters is a really good example. Also like Beej's C programming tutorials and like the SDL tutorial. So those are a couple examples of really great programming books that I really enjoyed. And the common thread was that they take a more lighthearted approach, They're coming at it, looking at it with, you know, like some love for like what you can actually do with the language, and they're taking you from knowing very little to being able to build something interesting and useful, and being able to add your own vision on top of that. And they're bringing you through all of that very quickly. And I really wanted to replicate that, and it seems like people like the first few chapters that are out right now. So I hope that means I'm succeeding. But I designed the book to be just fit as many different projects in there as possible. I'm writing in, you know, like silly like narrative pieces, and like adding my sense of humor on top. Um, so I'm trying to really write a book that exudes the passion that I have for Zig, and sort of gives you that, like, you know, old school hacker spirit, and also just teaches you a ton of practical knowledge about the language and about things that you can do with the language, and equips you to take that into you know, your job or a hobby project you want to do, or whatever you want to do with Zig. So that's what it's about. That's what I'm hoping to achieve. Yeah.
It's also still quite early. I mean, I was just taking a look because I remember there's only like 3 chapters so far, but it seems like you have another 8 chapters, right? So what else are we looking for within the book then itself that's kind of still, you have another update coming out soon?
Yeah, we should have some new chapters coming out soon. Chapters 4 and 5 are in the finalizing stages. Um, so I think, I guess you can look forward to. I think chapter 2 is really, to me, the to me part 2 is really my baby for the book. I think that part 1, I'm really trying to just get people to understand Zig, and be able to write Zig code reasonably confidently. And part 2 is really, I'm taking you through a more whirlwind tour of some different topics that that I have a lot of passion for. So like we start out with building a web server using comp time, to like build a little like word game, and then putting that on the web. So that, I think, uh, it gives you some pretty cool stuff to work with immediately. Um, we're also going to work with C integration. We're going to work on a chip 8 interpreter, which chip 8 is just a simple bytecode language from, I think, the 70s. And there's already like some like chips for it. It's kind of like a fantasy console, like the Game Boy or something, but a much older version. So we're going to build that. I know we're going to build a chat server. I'm excited for that one too. Just making a chat room. I feel like I'm missing something important, but you know, that's okay. I think there's a lot of different. We're going to work with graphics, so OpenGL, which I think there's a lot of. I think that a lot of people coming to language that I've seen want to make games at a systems level. They want to build graphical stuff and understand that lower layer. Um, so OpenGL is a pretty interesting thing to know. It's interesting historically, so that's going to be cool too. Um, yeah, so a lot of different projects and touching on different topics, and I'm trying to do it all in a Ziggy style, so you get the philosophy in there too. Yeah.
Okay, I mean, it sounds pretty exciting. Like, I kind of looking forward to the OpenGL one because I, want to play a little bit with with graphics and stuff. So that sounds pretty fun. Yeah. So I just want to say one more time, the book's name is called Systems Programs with Zig. Definitely something I want to really get a deeper look at. It's like I only saw 3 chapters. I thought it was 3 sections first. I thought we're actually towards the end of the book, but we're still far into the beginning. I suppose. So hopefully it won't change too much because so far it sounds pretty solid. Sounds like a pretty interesting read. Yeah, I mean, other than that, is there anything that we didn't touch on that you wanted to touch on before we sign off?
I don't think so. I'm really happy I got to talk so much about Zig today. I have endless things to say. Yeah, so it was great to talk to you. Great to be here.
Yeah, it's great to have you on and kind of spread the word about Zig because it seems quite popular, like in my circles, in terms of people talking about it and using it, or whatever. But I'm not too sure about in other circles if they're talking about it. I wouldn't be surprised if they're not because, like you said, there's no like paid published books out there that about Zig, which I really had no idea. I'm really kind of shocked to hear that. So I'm happy to hear that. I'm actually making history over here. I'm talking to one of the first ones out there. So it's great to have you on and to kind of help spread the word about Zig. Yeah. So again, thanks for coming on, and yeah, maybe we'll have you on for Zig's second edition. I'm not sure if you're going to be up for that. It's already a hassle doing the first edition now.
Yeah, thank you. Yeah, hopefully 1.0 happens at some point, and the second edition can be, a very long-lasting book. Yeah.
Yeah. Well, again, thanks for coming on, and like I said, hopefully we'll have you on again in the future.
Thank you.